In every programming language that I know, strings are implemented using arrays. And it's sometimes important to understand that underlying implementation in order to avoid common bugs which can cause efficiency problems in your code as the data scales. We're going to look at a simple example, which is building up a string from in pieces. I'm just going to take an asterisk and I'm going to build a string of length n by appending one asterisk at a time. And I'm going to try doing it two different ways. One is the first thing that most people think of, which is to use a string variable and to concatenate each time updating the variable. The second way is something that you may not be aware of. It's the use of a string buffer in Java. The string buffer class is something that's used to make strings. And it has an append method which allows me to add a star onto the end of the existing string. And then I can convert my string buffer to a string by invoking the toString method. This is a linear time operation, so whatever the length of the current string in the string buffer is, it gets copied out as the result. Let's look at the performance of these two different ways of making a string. And in my main method, I'm going to just first try a string of 32, and I want to show you what that looks like. So I'm actually going to print out the string that was built as a result of doing that. And then I'm just going to jump in and start building larger and larger strings to see their performance. So if you count the asterisks here, you'll see there's 32 of them. So this is actually building a string of the right length. And then if we jump in and just sort of watch how the strings are getting built here, I'm counting the number of operations that I think are performed. And you can see that that is going up quadratically. And just to see that I'm not making it up, I've got the experimental walk log numbers to back that up. So this is actually doing a quadratic amount of work to build a string of length n. And that means that each of these concatenation operations that are being performed here is amortized linear time. This is not a constant time operation. It takes time proportional to the length of the result. And this is a real common bug I have seen even professors of this course make, which is to take a data structure and try and print it out as a string using this kind of concatenation. This is how to print out an array in quadratic time and you will be fired. It's just a mistake you don't want to make on the job. It's okay to make it in this class. This is where we're learning this stuff. So how are you supposed to take an array and print it out as a string? Well, Java provides the string buffer class for exactly this purpose. And what a string buffer does is uses an underlying array of characters to sort of build up a string. Strings are immutable in Java, just as they are in many languages. And that means once you've built a string, you're not allowed to change it by adding things. Therefore, the string buffer you can think of as sort of a mutable version of a string. What I do here is I create the string buffer, I append elements into it, and at the end convert it to a string. Each of these appends takes constant time, amortized, because there's an underlying array. So Java is doubling that array or 1.5 timesing that array. It's changing the size of the array as needed, but it's doing it to give me amortized constant time for each append. And therefore, I get amortized linear time for this algorithm here to make a string. And again, you can see that borne out experimentally. I can create quite large strings here. I have a string of almost 500 million characters that I can create in 7 seconds. With the quadratic algorithm before, Already for a string of 1 million elements, I was taking more than 2 minutes. And so using concatenation to build a string in this way is just a bug. And even for relatively small data, for 65,000 elements, it's taking half a second. And you don't want that happening on your application. For 65,000 elements here, we're, at a nicer number. We're down in milliseconds. So Java's string buffer class gives us an append operation that works in amortized constant time. And thus we can build up these kind of strings of some length in linear time. To see this in action, you can look at the resizing array queue or the resizing array stack. Each of these has a toString method which uses a string builder to build the string representation of the data structure. This is the correct way to create a string for a collection of length in using a string buffer.